Let's talk about NoSQL with MongoDB. What is NoSQL? NoSQL, or not only SQL, is a term used in several technologies where the nature of data does not require a relational model. Perhaps you have a large volume of data, you simply have too much data and too costly to use a relational model to store that data. Perhaps your data come from different structures and shapes, and perhaps you also have dirty data, so you cannot force all the data into a perfect structure where you can use the relational model. Perhaps you have high computational needs, such as for the availability of data, for scalability of your computational models on the data, and high performance. So for different reasons, a NoSQL database may be a better selection compared to the traditional relational model. We are actually talking about a number of technologies here because NoSQL is just one name that refers to many different technologies. And there are a few types of NoSQL stores that we would like to take a quick look at. So the first type is called a document store, such as a MongoDB store or CouchDB store, where data are organized as a collection of documents. There is also this notion of key value store, such as Cassandra, Dynamo, HBase, and so forth, where data are stored as key value pairs without predefined schema. Sometimes you also have graph data, and perhaps you need to use a graph-based store where data are stored in a graph structure with nodes or entities and edges connecting them. And so there are certain technologies such as Neo4j that are best suited for this kind of storage. So these are some of the major types of NoSQL databases. So MongoDB is one implementation of NoSQL databases. And as we said, it's a document-oriented database for high performance of storage and retrieval. And it uses this particular format called BSON, which is a binary implementation of the JSON format, the JavaScript object notation format, which is very popular today. And MongoDB has a wide range of very useful features, such as for query, for replication, for load balancing, and so forth. When we talk about NoSQL, it's often useful for those of you who are familiar with SQL or relational databases to relate the concepts in non-SQL to a relational database management system. So in MongoDB, for example, there is this notion of the database, which is quite similar to the database in relational SQL databases. Okay, a database is a set of collections in MongoDB, and the collection can be likened to a table in the relational database. But the collection is different from a table because you do not have to predefine the schema, the structure of the collection. And here, a collection is a collection of documents. And the document is similar to the notion of a record in the relational database, or record, or a raw in the relational database. And the field, each field of a document is similar to the field in the relational database as well. But here, as I said, you do not predefine the structure of the collection. And so when you insert a new document, for example, you can insert a document with a different set of fields. Now, to use MongoDB, you can either use the MongoDB on the cloud directly, or you may be able to download a community server, which is free, and install it on your machine, either on Windows, on Mac, or on Linux, and play it on there. So you can interact with it locally. So to install on Windows, you simply download and install the MSI installer and follow the steps there. On Mac OS, the best way is to work with Homebrew. Once you have Homebrew installed on your machine, it takes a few steps to set up MongoDB server. So once MongoDB is installed, there are a couple of steps to make sure it works. First is to set up or create a DB directory. And by default, you can create a /data/DB directory, which will be used by the MongoDB server to store data. So once you have that directory created, you can then run the Mongodb, which is a server or daemon that listens on a particular port to take care of a command that you use to interact with the MongoDB system. And then you can run Mongo, which is kind of the MongoDB client side on the command line, so that you can type in your commands for the MongoDB to store or retrieve data. So let's go through some of the steps, and we are going to actually go to the actual terminal to play with some of these commands, but I would like to go through a few things before we go there. So once you are on the command line, you can type Mongo, okay, and by default you will connect to the MongoDB server or daemon on the same machine, okay, locally. So at the prompt, you can use any MongoDB command, such as show DBS. This is to show a list of databases currently hosted by the Mongodb server. Now let's clarify a few concepts here. A MongoDB database is a physical container for document collection. So you can have a number of collections in a database. Now to use or open a database, you type use and then the name of the database. And if you want to show what are the existing collections in the database, you can type show collections, and that will give you the list of collections currently in that database. Now, to use the database does not have to exist yet. Okay, you can use a new database, and when you actually insert data into a collection in a database, that database, the container, will be created for you. A MongoDB collection is a group of documents, which is similar, as I said, to a table in a relational database. Okay. Now the benefit of using MongoDB and the notion of collection is that the collection can actually be split across multiple shards. A shard is kind of a division, a distributed data set that can be spread across multiple machines. So this is a great benefit if you want to scale out your resources. So for example, if you start a small database on MongoDB, in the future, your data may grow in volumes. And so if one machine is too limited to host the entire data set, in the future, you may add machines to it or add shards to the entire MongoDB cluster. You may be able to add tens, even hundreds of machines to host a growing data volume. Now, A MongoDB document is a record and it implements the schemaless model. So we know a database is a set of collections, right? And a collection is a set of documents. And a document is essentially a record, right, about something, about an entity. So, and a document here we said it is schemaless because documents do not have to have the same fields, right? So when you insert documents into the collection, each document can come with different fields. And this is very different from a relational databases where you have to have a schema or structure predefined before you can even populate data. Now, in MongoDB implementation, the format of a document is similar to JSON. So you use the JavaScript object notation to create a piece of data in there. But when you insert the piece of data into your collection, it becomes a binary representation with the so-called bsum on the disk. Now let's go and test some of the features in MongoDB. So we're going to go to the command line or terminal to just play with the MongoDB together. So we are going to have two command line windows. One is to bring up the so-called Mongodb, which is the server of the MongoDB system. And then we are going to have a second command line window where we run Mongo to start the Mongo shell, right? So the Mongo shell is a client that sends our command to the server to be processed, either to store data or to retrieve data from there. In this demo, what we are going to do is run the server and the client on the same machine on our local computer here, okay? But remember, in the future, in the actual environment, what you do is that you may need to connect to a different server, right? So using the same Mongo command line, you may be able to connect to a host on mongodb.example.com, which is not something real, but something I made up here. So you can connect to a different host on the internet or in the internal network of yours. And you can also specify, of course, the port on which you want to connect to, okay, where the MongoDB server actually runs. Okay, so you can connect to a different server and interact with it. And so the idea is that this is the client that takes care of your command and that interacts and connects to a remote database server. So now we have the two command line windows here. And in the first one, we can type Mongodb D for the daemon or server to start the server. Okay, so once it is started, we can go to the second command line and type Mongo, which is the client side. That would by default connect to the server on the same machine here locally. Okay, but if you want, you can type like, okay, Mongo host and then the address of your MongoDB server and then the port, okay, whatever port that the server is running on. But for now, we are only going to connect to the local server here just to test this technology out. Okay, so hit enter. It's going to give you a number of messages. Now I'm having some configuration issues here. I will take care later. And so you are seeing a longer messages here. But once you enter into this interface, you are seeing this greater than or bracket for the prompt. And so you are there with the MongoDB. And on the server side, if you noticed, it actually also shows a message about the new connection from the client side as well. So now let's try some commands to interact with MongoDB. And so as we know, and let me make this up here. So you can use something like show DBS to show the current databases in there. Okay, so we have a number of databases on the server here locally, and so we can use a new database or an existing database. So for example, let's suppose we want to manage some data about a college, and so we are going to use the college database. Now, the college database does not have to exist now. It can be a totally new database, and we can even try to add new data to the database. Okay, so now we type use college is going to switch to the college database, and we can start to populate some data there. So for example, DB. So DB here is a reference to the current database, which is college. And then suppose you want to have a collection called students. Okay, again, the students collection here does not have to exist yet. Okay, but it could have existed, but it can also be a new collection. And so, as we say, a collection is a set of documents as part of a database. And so for the students collection, perhaps you want to kind of insert and add a new student record. And so the syntax here is db dot the name of the collection, which is students here, dot the method they want to perform. Okay, so here we're calling the insert one method or operation to insert a new record. Now, as I said, in MongoDB you use this so-called JSON format, okay, or JavaScript object notation. And when you create a new object in JSON, you use a pair of curly braces, okay, and inside the curly braces you have a set of key and value pairs. Okay, so perhaps for the student we want to have a name, and the name is John Smith. Okay, and so the key and value pair are separated by the column, and then perhaps John is in the program of data science, and perhaps the class year is 2024. Okay, so you have multiple key value pairs separated by the comma. And now if you're done, you can hit enter, and this new record will be inserted, if everything goes okay, into the collection, and the collection is called students. Okay, so the message here actually says that the acknowledged true, which means the data record has been acknowledged, and there's an ID associated with this newly inserted record. Okay, so you can continue to do that with more records. Now, as we discussed, the collection in the MongoDB database is schemaless. So that means when you insert a new record, it does not have to come with the same set of fields. Okay, so let's try another record. So again, db.students.insert one, and now this time I'm going to try a set of value with different fields. Perhaps we can continue to use the name field. So there's one common field for Mary. Okay, and perhaps for Mary, we don't know about her program, so there is no program information, but perhaps you know the age, right? So we can have an age field, and the age is like, okay, 20. Okay, so you see that here we are inserting a new record for Mary. with name and age, and the fields are different from the previous one. Okay, and we can do that. Okay, so we are having a couple of records here with different fields, and this is kind of the idea of MongoDB having a schemaless collection. Okay, now that we have a number of records, we can actually update, right? So we can, so for example, if you have some student records, they want to update on perhaps on the status of acceptance, and perhaps these are applicants, and you want to update their status. And so perhaps there are certain rules that you can use for this update. For example, let's consider that for the sake of discussion, if the student's age is greater than 150, perhaps it's too old for college and we should reject. And so in this case, we can use students.update many. Suppose there can be many students with that kind of age, and we want to reject those. Okay, so what we can do is to use the update many operation, and then we can, in the first part of the of this update method, okay, there are two major parameters. The first parameter is for the condition. Now, under what condition you want to do the update. And then the second part is really to do the actual update. So we're going to set the condition first, okay? And the condition here is that the age should be greater than 50, okay? So we are writing the whole syntax in a JSON format. But pay attention here that when you see a $sign, okay, a $sign indicates that there is a special operator in there, in your expression, in your JSON object. So for example, $GT indicates the greater than operator. So the condition here says age, which is the value of the age field, must be greater than 150 in order for the update to happen. Okay, and so in the second parameter, where we have a pair of curly braces, we are going to actually do the update, and we use another operator with the $set to change the value of that student record, and we can say, okay, want to set status reject. Okay, so when the condition is met, we want to change the value of the status field to reject. This is the whole update statement here. And we can hit enter, and it says acknowledged, and the match count is 0 because no one here is more than 150 years old. Let's just try another value for the condition for the sake of discussion. Okay, so perhaps we want to say, okay, if someone is less than 15 years of age, it's too young for the college, and we want to reject. Okay, so let's try this instead. So $ALT is for less than 15, so we can try this here, still 0. Given that we already have Mary with age 20 in the collection, we can try something like 21, just for the sake of practice here, and hit enter, and it says matched count is 1. And so that means one record has been matched and has been updated to the reject status. Okay, so that is the update command. Now let's try also delete. Sometimes you do want to remove records or documents, I should say, in the collection. So what we can do here is db students.delete many. Okay, And again, it comes with some condition here. Okay, so delete, and we can have status reject. Okay, so the entire statement here means that if the status is reject, we want to delete that record. Okay, and delete many means that there can be potentially a number of documents meeting this particular condition. So let's try this, and it says delete count is 1. So what we can see now, obviously, is that the record for Mary has been, the document for Mary has been deleted from the collection. Now let's try some query to retrieve data from the Mongodb database collection. Okay, so the first command that we can try is db.students. Again, students is the collection's name. .find. So the find operation will find documents meeting certain conditions. Now, if you do not specify any parameter in there and say find, it's going to actually retrieve all documents from the collection. Okay, so this is find without parameter is to find all. Okay, to find all documents from the collection. But you can certainly provide some parameters or a special query expression in the find statement. So for example, db.students.find, and then I'm going to add a query expression. Okay, and so the expression can be something like, okay, class year less than 2025, for example. Okay, so here I'm using the $LT, which is for the less than operator, to make an expression so that I'm going to find all students who will graduate before 2025. Okay, so if I hit the command, let's do it, students find, and so open close the curly braces. Within the open close, I have this field name that I want to match, and then another close. Okay, so another pair of curly braces for the actual condition. So LT 2020, let's find 21. Okay, and see if there is any result. If we do this, hit enter, there's nothing. Okay, we can try 2025. Okay, and hit enter, it's going to show you a number of records meeting this particular condition. Now I would like to switch back to the presentation to show some of the more complex commands, just to review the things we can do with MongoDB and look at some more complex query expressions and so forth that perhaps may take longer to type here. So just now we had a taste of interacting with MongoDB using a few command line statements. So now I would like to kind of do a quick review of what we have done here. So again, if you use show DBS, it shows a list of databases on the MongoDB server. And if you want to switch to an existing database or to a new database, you can use this use followed by the name of the DB to switch to that database. And once you switch to the database, you can use the DB to reference that database and start to call particular methods or functions for operations, such as to insert a new document. So DB is a reference to the current DB, which is college. .students is a reference to the students collection, and then .insert1 is going to insert one new record. And you can provide the document in the JSON format with fields such as name, program, and class year. Now, you are not limited to any particular field. because it's schemaless, so you can add any document with any fields into the collection. And as a result, you will receive an acknowledgement from the MongoDB server about whether the record has been inserted or not. And you can continue to do that for additional students. And one thing we noticed is that in the end, we also insert a student record with a different number of fields, right? So we insert a record for Mary and a field for the age of Mary, which is not in other documents. So again, we can use different fields for different documents here. To update, we use the update many, and there are two basic parameters here. The first parameter is to set the condition. Okay, a document has to meet that condition in order to be updated. And then the second parameter is for the actual change. And so how you are going to update and which fields you are going to change and what value should be used for that change. Okay, so here we consider the condition that if someone's age is greater than 150, we should set a status to reject. Okay, and again, these two parameters are both in the JSON format. So when you interact with MongoDB, it's very important to get yourself familiar with the JSON format. Okay. To delete, we can use this .delete many. So here it deletes all documents that are marked as reject. To find, we can use the find operator. Okay, so .find, if there is no parameter provided, it's really retrieving all records and all fields. But if you provide some parameters, you can both limit the number of documents you retrieve as well as the number of columns or fields that you want to show. So here is an example to do that. So in the first parameter in the find statement, you actually provide a JSON format with a condition. And the condition here is that class year should be less than 2021. Okay, so this is a condition which limits the number of documents you are going to see. So this is the filter. And then the second parameter here is to set which fields you are going to show. And so name 1, program 1 is to say that I want to show the name field and the program field. Again, if you want to select all documents from the collection, you use the find statement or method without any arguments. Now, to count the number of documents you found, you can use this .count. So that suppose we want to see how many documents are in there in our students collection. So you can use this db.students.find without any parameter, which is retrieving all documents, and then .count is going to count the number of documents in there. You can find documents based on a field value. For example, I want to find students in a particular program, such as data science, so I can use this find. And again, the condition should be expressed in the JSON format with a key and value pair. So program, which is the name of field, and then the value we want to match, which is data science here. So it's going to retrieve all students in that program. We can find one document based on the field value. So sometimes you just want to check whether there's any data in there. So perhaps the first document is what you want to take a look. And so you can use the find one, which is going to apply the same condition here, but it's going to only return to you the first document that meets the condition. The explain operation is also useful to help you understand how the method is executed. So it tests the query expression here and reports information about the execution. Okay, so it helps you understand what's happening in the backend.